Okay, so when we have a question like this that contains sine and cosine, here's a hint. We're going to use a Pythagorean identity. Cosine squared plus sine squared equals 1. So our goal here is to solve these equations for cosine and sine and then substitute them into this identity. It can be done with any identity. It just so happens that this one works really well because we have a cosine and a sine, and they are both in this identity. Okay, so let's go ahead and solve x for cosine. So instead of solving for t, we're actually just solving for cosine t. So cosine t would be x minus 1 over 3. And then I'm going to solve y for sine, the y equation for just sine of t. So sine of t would just be y over 2. So now I'm going to plug this in here and square it. And I'm going to plug this in there and square it. So that will give us x minus 1 over 3 squared plus y over 2 squared equals 1. Simplify that a little bit more so that it looks like the conic section equations we learned previously. Might not hurt to go back and look up those equations as a reference. I mean, you can do this stuff without it, but it's helpful. So what shape would this graph be based on this equation? It's a plus, so it's an ellipse, yes. Okay, so the x minus 1 and the y squared, that tells us that the center of our ellipse is at 1, 0. And then we have the x direction, I think we called that a, would be the square root of 9, which is 3. And b direction would be, or the y direction, plus or minus 2. So center at 0, or 1, 0. And then left or right 3 from there, and then up or down 2 from there. So there's where our ellipse would be, and of course we know the parameter affects that. If we look back at the problem we did on Wednesday in section 8.2 that goes with this, we'll discover that it only goes that far, and I believe the orientation went this direction, but it starts here and ends there, so it's only like 3/4 of the ellipse.